I'm a senior data scientist with IBM, and I'm here to take you all through the integrated solution that we have built using IBM Cloud Pak for Data and AWS. What we are going to do today is to build a couple of predictive models on a COVID dataset, which is available at this URL here. And this dataset is for Belgium country, and it has uh, different types of data like confirmed cases by date, age, and hospitalizations, and mortality, and all of that. What we are going to do is we are going to download two data sets from this URL, confirmed cases by date and hospitalizations, right? We will download it into our local file system, and then we will go ahead and upload that into uh, the AWS Amazon S3 storage service, where we can upload that into one of the buckets that have been created, right? Uh, what I have done is I have downloaded the dataset and I have uploaded them here. And the next step is to create a SageMaker instance and access the notebooks which are in the SageMaker instance, right? You can see here there are 4 instances created, out of which I have opened the predict cases instance, which has a couple of notebooks here, right? We'll start with data pre-processing notebook. So what this notebook does is it will extract the data from Amazon S3 bucket, and it will display all the data sets which are available in that bucket, where we'll be using only the age and the hospitalization data. We will merge the dataset on a couple of attributes, and then we'll start our analysis using pandas profiling. We can see that we have run the pandas profiling, and it says that there is about 0.4% missing information, right? And it also gives very detailed information of all the variables which are available here, right? It covers all the statistical analysis, histograms, frequency graphs, and all of that, right? And once we have done that, we are going to deal with the missing data. We will go ahead and remove them, right? And then we'll run the pandas profiling again for the analysis, and we can see that the missing cell information is 0%, right? And then we will go ahead and do feature engineering. What this step does is it will identify a new attribute which we will derive from the data sets, and we are going to use that attributes for creating predictive models, right? In this, what we are doing is we are coming up with a total cases attribute by doing an aggregation of two attributes, right? Cases and new in attributes, right? And we are going to drop the attributes which are not needed, because this would be a time series data that we are creating here. So it will have 3 attributes: date, region, and total number of cases. And then we are going to create a data set on basis of the country, right? And then we will write the data set into S3 bucket for ingesting it into SageMaker models. And we will be doing the second feature engineering, right, to calculate the risk index per region. So what we are doing here is, for each date, we are identifying which region has maximum cases, right? We are identifying that as 2. Which region has minimum cases is identified as 0, and the second lowest is identified as 1, right? For that, we are doing all the calculations here programmatically, and we are able to identify the risk index, which will tell us, what would be the risk index per region for that particular date, right? So we are going to build this multi-class classification model in Amazon S3, right? And write this risk index data also into the S3 bucket, right? The moment we run this notebook, there will be 5 files created, 3 for each region on the time series, 1 for risk index, and 1 for country level time series information, right? And the notebook runs in about 75 seconds. Now going to the next notebook, what we can do is we can review the country level time series forecasting model that we have built. And this notebook runs on AWS SageMaker as well as IBM Cloud Pak for Data. You can see that we are trying to analyze the trend, we are splitting the data set, we are converting the time series into a regression problem, and we are fitting a 2-layered deep learning neural network, long short term memory, and we are building the model, and the model, even though the data set has a less number of rows, it is still giving us very good accuracy. In fact, the accuracy is more than 90% for this. Train accuracy is 97 and test accuracy is 87%. And then we are doing transfer learning, we are demonstrating how to save the model into directory, and how do we write the model back to S3 bucket, right? We can also save the model architecture, and how do we load the model architecture from S3 bucket into this. All of that is demonstrated here. The same notebook runs on IBM Cloud Pack for Data as well, right? Now, going to the next notebook, which is SageMaker Deployer, right? So in this notebook, what we are doing is we are building a multi-class classifier using SageMaker Linear Learner, which is an inbuilt algorithm, right? We are importing the libraries into the notebook, and trying to access the S3 bucket using the credentials, listing the files which are available, and we are picking the risk index file which was generated using the previous notebook, the data prep notebook, right? And here we are dropping the date, and we are ensuring that it has three attributes: region, total cases, and risk index. What we are going to do is we'll use region and total cases to predict the risk index for each region on any particular day, right? So we are converting the data frame here and splitting the data sets into 80/20, right? And we are also assigning the labels here. And here we are building the model using linear learner, right? Using the SageMaker linear learner uh, algorithm. We are starting the training job here, and we are also deploying a model hosting endpoint here, and we are evaluating the model performance here. You can see that the model is doing reasonably well with very less data. It is only about 2,200 records, right? And we can see that how we are able to generate new predictions on the data, right? And if we want to do some new scoring, we will ingest this data from the S3 bucket, and we are able to generate predictions on the new data set, right? And then there is also balanced multi-class estimator, which will provide slightly higher accuracy if we run that. But for this purpose, we have used the multi-class classifier predictor, and we have generated the endpoint. How do we access the endpoint? We can go to SageMaker instance and click on endpoints, and we see that there is a linear learner endpoint which is already generated, right? Now, what is the next step? We can directly save this notebook and load it into IBM Cloud Pack for Data environment, right? By creating a project and loading the notebook into the environment, and we'll be able to run the exact notebook with minimal changes, and the notebook will be able to deploy another endpoint in the SageMaker platform, right? Now that we have run the notebook in Watson Studio, the next step is to monitor the SageMaker model, which is deployed, right? And we will use Watson OpenScale service to monitor the SageMaker model. Here you can see that there is a notebook which we have already created. We'll start with requirement uh, creation, and we'll provide the cred to access the IBM Cloud and buckets, right? And we'll create a data mark. We will bind the machine learning SageMaker engine into that. This SageMaker cred is coming from the notebook which we ran in SageMaker, right? And then we will create a service provider. We will add the subscriptions for that, so that whenever there is a new data coming, the Watson OpenScale service will be able to monitor that without any problem, right? What are the feature and categorical columns which are there, and then we are importing the data here, and we are creating a paylog table. And here you can see that feedback logging and quality monitoring, we are trying to set it up here using the uh, code that is given here, and we are reading some sample data sets for the feedback logging, and then we are running the notebook, right? And then we are setting up the notebook for evaluating fairness, drift monitoring, and explanation for the SageMaker endpoint that we have created, right? And we are displaying the records for that data set. And here we are enabling the fairness run, and fairness monitor, and same for drift and explainability as well. Once we are done with running everything, we can click on OpenScale dashboard. That will open up the OpenScale instance. And for drift detection, we will have to build another model, which is already loaded in the Watson Studio environment, where with installing necessary libraries and ingesting the data, we will go through all this uh, code programmatically in a sequential order, and it will create a drift detection model for us, right? And it will also create a training data distributed JSON file, right, which we will download that into our file system, and then we'll have to upload it into the Watson OpenScale environment, right? Now, this is where the OpenScale has been configured to monitor the linear learner model which has been created. As you can see that the model fairness has been evaluated and there are 0 alerts, and the same is for quality as well, right? And if we want to configure the monitor, we will click on configure, and we will see what all aspects have been set up. We have set up fairness, we have set up quality, we have set up drift using the notebook. Click on the second tab in the left navigation pane to access the explainability metric. We'll have to select the linear learner model that we had created in the earlier step. And on the left side, you will see the transaction IDs. We can select the first transaction, which is the first row, to get the explainability. As you can see, for this row, the total cases is having a significant impact, and the predicted outcome is 2, which is high risk. And if we click on inspect tab, we will see the original value and what are the feature names and the predicted outcome. We can change the new value to say 0, and then click on score new values to understand how the prediction would change for a different set of values, right? So for 2 and this number of cases, the predicted outcome has changed to 1. So this is how we can understand the explainability metric, which we have configured using the notebooks ran through Cloud Paper Data Console. So this is how we can ingest the data from multiple sources, load them into different databases, right? And ingest them into the SageMaker notebook instance, and build the models, create the endpoints, and then port the entire model into Watson Studio under Cloud Pak for Data. Create the deployment from Watson Studio, and then plug in Watson AI OpenScale service to monitor the SageMaker deployment, right? Like how good is the model? Is there any bias in the model, right? How fair is that model? And how do we understand the model behavior? All of that can be monitored using the SageMaker instance. So this is all I had. I hope you enjoyed watching it. Thank you.